Hello and welcome. We're looking at rotations. Alright, much like all the other transformations, I want to make sure these vocab words are clearly defined so that when I use them, you're not lost. First term here is preimage. It's the look of an object before you transform it. So it's the original thing. Like in a problem, it says, here's pentagon ABCDE. Now apply the transformation. Blah, blah, blah. Here's a triangle, PQR. Here's a trapezoid, WXYZ. Then you apply a transformation. That's going to be called your image. So because both might be drawn on screen together, if they want to identify one or the other, if you want to do it and you want to say what happened from preimage to image, you know which one's which because they'll have corresponding points. Here's an A prime, B prime, etc. But something happened to them. Now, not color change. That's just to notice one and the other. But here is a pentagon and here's a pentagon. What changed? For here, it's really only a translation. These guys all dropped down. A went to A prime, B went to B prime. They all went downward some amount. And it's the same amount for all of them. That's called a translation. Now, this also went down, but this went down in another kind of context. This is called a reflection. If I make this dashed line kind of the reflection line, a mirror, if you will, all these things went down a certain amount. Q reflected down to Q prime. You might say it went down there, but once you see P and P prime, it didn't just go down there, it reflected across that line there. You can see P and P prime are the farthest away from one another, as they should be. This is a mirror image of the other guy right there. They are symmetrical. And then here's a final one called rotation, where if you imagine, it's kind of a toppling over effect. If you imagine there's a point hinged on Z here, everything rotated downward 90 degrees, and you can kind of see the end result of all this. W goes down to W prime right there, X goes down to X prime, Y goes down to Y prime, kind of swings on through. And if Z was at the center point, if I could make it so, you would see that rotation exist. Now, all three of these transformation types are called isometries. That's when the preimage and image are congruent to each other. You can find A and A prime, the angles will be congruent. Segment BC prime will be congruent to one another. The size didn't change. They might have changed their orientation, where they're located, maybe even their color, but they did not change their size whatsoever. You find corresponding parts, they will be congruent. So that's true for all translations, reflections, and rotations. It's not true, though, for what's called a dilation. That's another kind of transformation. Although corresponding angles might be congruent with these two arrows here, you can see that clearly sizes have changed from one to the next. These are not congruent to each other. Even though I'm marking congruent marks, I'm just indicating where they are. These are no longer congruent to one another. So dilations are not isometries, while translations, reflections, and rotations are. Okay, this one's specifically on rotations, though, so let's take a look at the definition, talk about it, do some examples. Rotation is the movement of an object around a pivot point where every point in the object remains equidistant to the pivot point from its preimage and image. So let's talk about that definition for a second. If you and your friend are holding on to a rope and you stay kind of in one place, okay, but you rotate around, you'd say to your partner, to your friend, say, hey, start moving left and right, and you start rotating. Say this is your friend right here and holding onto the rope, and this guy's you holding onto the rope, and he starts swinging, he goes over here, and now here's where he is. Call that his image, right? You, though, are still holding onto the rope with him. You're staying right in the middle. So you're rotating around here. You're not moving. He's rotating around here, okay? He is staying equidistant from you. Not only that, but he's always facing you. Pretend like his eyes are looking that way, and his eyes are looking that way, and if he was over here, his eyes are looking that way. That's kind of what the rotation will be like. Only we're going to do it for bigger objects, so you want to know what that's also going to look like as well after rotation. Because what happens is this changes its look in where everything's facing. A will no longer appear to be on top when everything rotates over. Instead, A will appear to be on bottom. And I'll give you an example of that as soon as I can. So to give you the look of the rotation before I actually rotate, I'm going to go ahead and give you an example using circles, because that's kind of what we're going to be doing, because everything will be equidistant from each other as it was. If I draw circles here from P out to A, where there's a certain radius of length PA, P out to B with radius PB, and P out to C with radius PC, if I lock these up and group them together, I can actually rotate this triangle now for you to show you what it looks like after I do some certain rotations. So let's take a look. I'm going to grab this and start spinning it. Now look what it's doing. Everything's staying the same distance away, as you can tell by the circles, and everything's rotating. Now, this is about 90 degrees. Well, this is exactly 90 degrees right here. Here's an example of a 90-degree rotation for an image from pre-image. 90 degrees. So look where everything kind of went. A, which was originally on top, is now resting as the lowermost point, and it will again if I rotate another 180 degrees. So it goes upside down here. This is not the same thing as reflecting this across a line where point P is on. This is different. This is a rotation. In reflection would end up looking kind of like this. Well, not even close, but reflection would go across this way. C prime would be over here. If I do a rotation, check out where C prime ends up. It's going to be over on the other side. So rotation has something kind of spinning about a certain point. In this case, we're calling that its center. And we're going to utilize that when we end up doing all this stuff right here. All right, so more about the definition before we do the actual example. The amount of rotation is provided by a number of degrees and direction. So we talked about degrees just a little bit, talked about 90 and 180. Now the number of degrees will range from 0 to 360. So somewhere there, if it was 0, wouldn't have moved at all. If it was 360, the image would be in the same place as the preimage. Won't make sense to go more than 360 for now. Now it also has direction. If someone asks you to rotate 90 degrees, you might ask, which way? Right? And you don't mean, they might say left or right, but we're going to talk about clockwise and counterclockwise. By default, if it does not indicate the direction, assume it means counterclockwise, which might not seem normal for you, but just make that assumption. If the rotation's 180 degrees, direction wouldn't be necessary to provide anyway. It wouldn't matter because 180 clockwise or counterclockwise puts you in the same place in general. Okay, so let's go ahead and do an example here. We're going to rotate triangle ABC 110 degrees about point P. Now for me, it won't really be possible to just do on a piece of paper without a protractor. In this case, I'm also going to use the compass to indicate lengths. So the protractor, once again, notice how when A was rotating, it stayed the same distance away. It stayed on that circle. So we're going to make sure, using a compass, that we do exactly that. So for the protractor, I'm actually not going to spend time dibble-dabbling with this tool right here. I'm just going to mark 110 degrees right now and get that point, and I'm going to go ahead and use that for myself. You would use the protractor, however. I mean, I'm still using 110 degrees, but that's what you do. You would line it up so it gets to 110 degrees. So I'm going to do it, for instance, going from point P to point A right here. Now, as you can see, here's point A on, let's say this was 0 degrees. If I wanted to rotate 110 degrees, I would swing it all the way over here. This line would swing over here. And if I make one more side for myself, then I know that point A prime will be somewhere on this segment right here. So I could actually remove this portion, and this might be what's drawn on your piece of paper because you might not have all the other essential things like this computer tool right here. I'll save this 110 degrees for the next, for point B, but let's go ahead and look at point A right here. So again, an angle is made for 110 degrees right here. Okay? A prime will be somewhere on this segment. To figure out exactly where it is, I have to find the length between A and A prime, between P and A right now. So if I find the distance away using my compass, I can now take that and I can measure it over here and say, okay, I know that A prime will be the intersection of that arc and that segment right there. That's where A prime rests because that is the same distance away from P as A is. Segment AP is congruent. If segment AP was drawn right here, just see this one more time. Not only is segment AP congruent to segment A prime P, but this is also 110 degrees right there. And that was measured using a protractor, sort of. Okay, so I have point A prime, because this is what your paper would probably look like a little bit. let's find out where point B prime is. And to do that, I have to do 110 degrees. Now, by the way, I didn't mention this yet. I'm rotating counterclockwise because it didn't say which way to rotate. So by default, assume it's counterclockwise. So I have to find 110 degrees from a segment PB right here all the way counterclockwise to find out where segment PB prime would go. So if I bring this down, PB is about right there for 110 degrees going all the way around here. Okay. So to find out where PB prime is, I have to find this distance from P to B, and I'm going to mark that off over there. So before I do that, let's go ahead and draw this segment, because again, you would be doing this exact same thing. You'd be drawing a segment. You would not be able to keep this 110 degree arc right there. It would go away. This is what your drawing would probably look like so far. So to find PB prime here, the length of that, let's find the length of PB using your compass. So rotate it, find the general area. Okay, I'm going to go and take that, swing it over to this segment right here. I'm going to mark it off, and boom, that is the area where B prime would rest. Okay, if you remember what the 90-degree rotation looked like, remember how A was on the bottom and B was over here and C was up there? Well, it's going to kind of look like that. It's going to be 20 degrees more than that, but it'll kind of look like that. So as long as you recognize what the rotation should look like, if you imagine it in your head, or if you take your piece of paper and rotate it, which is something I'll be talking about later, then I think you'll kind of be well aware of the concept of this, and it's going to help out in the long run. Okay, my last one I need to do is I need to find out where C prime will go by rotating this thing P with C. So here's P to C right here. If I go 110 degrees over, I know that C prime will actually be up here somewhere. So I'm going to go ahead and take this last segment here, draw one out where 110 degrees is. Okay, you'd probably be using a straight edge for that. Once you find 110 degrees, you plot a point, then use your straight edge. I can actually get rid of that now. I don't need it anymore. So remember, this is the 110 degrees from here to here. So now if I take my compass and find out the width of PC, I can then find where PC prime will be. PC prime will end up somewhere up here. There we are. Now go ahead and plot a point right there. I'll call that C prime as best as you can see it. I can actually get rid of the compass now. It's not necessary for me anymore. My last bit I need to do now to make this triangle, you have to think about what you're doing here. Not every point will rotate, but you're not going to rotate every point. You're just going to rotate the vertices. These points, all the points that reside on the sides of A, B, and C, can now be connected like so. You can just go from one point like C prime, whoops, let's use a regular line tool, one point like C prime and connect it with A prime over there. Boom, I've made one of my sides. Here's A prime to B prime, and here's B prime back to C prime. And I've now made that triangle again, only this is that rotation. So if you think about how it's swiveled, if you need to rewind, please do so. But think about how it's swiveled around. Once it rotates over here, A and A prime are the same distance away from P. They're kind of on that invisible circle. B and B prime are the same distance away from P on the invisible circle right there. And C all the way up here, if you bring it all the way back down, it'll be going down to C right there. And they stay the same distance away from each other. And the orientation's kind of confusing at times, and if you have all these extra lines and arcs, which I'm going to remove right now, it might appear a little confusing to you. I don't want to remove that. It might appear a little confusing to you, but once you've done rotations a couple of times, you'll start figuring out what it's supposed to kind of look like. Now remember, rotations are isometries, which means that these are all congruent to each other. AB is congruent to AB, A prime, B prime. BC is congruent to B prime, C prime, etc. And there you are. That's a 100-degree rotation about point P in the counterclockwise direction for triangle ABC. Okay, example number 2 here, we're just going to rotate point A 3 sets of degrees, 90 degrees, 180 degrees, and 270 degrees, about the origin. Now this one's on a graph, okay? And the thing that's going to help us out here for you to kind of make note of what's going on is after I do every rotation, I'm going to name it with a prime thing, And I'm going to also count off what the vertices are here so you can start to make sense of what's happening. 1, 2, 3, 4, 5, 6 over, 2 up. A is at the point 6, 2. When I rotate this 90 degrees, now, didn't say which way, so again, assume it's counterclockwise. And I think the reason for that is because if you start taking something like pre-calculus, you start doing things with unit circles, and you're going to be going in this direction. The quadrants run from quadrant 1, which I'm going to make mention of the quadrants again. 1, 2, 3, and 4. And going counterclockwise kind of fits that pattern. And I really think that's the reason why they want to make that the default. That's not to say you won't do clockwise rotations, though. In fact, we might be doing it the next example. Anyway, so A is at the point 6, 2. Before I actually do, well, I'm going to do the rotation, but here's how I suggest that you probably start learning about perception of rotation. If you have a graph paper right here and you plotted your A point, what I want you to do is rotate your graph paper. Literally, rotate it 90 degrees. And you'll know that it's 90 degrees because if Y is sticking up like this, after a 90-degree rotation this way, Y will be pointing to the left over here. And if X was pointing to the right over here after a 90-degree rotation, X should be sticking up right there. So here's what a 90-degree rotation of your entire paper looks like. Boom, like that. Okay? I want you to notice where A is now sitting. A is sitting in the place where A prime will be sitting on your original graph after a rotation of 90 degrees. I really hope that makes sense what I just said. Let's go ahead and take a look at that again. Let me reset. After a rotation of 90 degrees, remember how A is staying, this is rotating about the center, about the origin. This is the only way that this is working. It's rotating about the origin. A is rotating about the origin. Notice how the origin's not moving. And as it goes to 90 degrees here, this is where A prime is going to sit at the point -2, 6. I'm actually going to write that down right now and make sure that I know that that's where it's going to be placed. This might be the way that you go about perception of these problems. I could try and talk about another way that I do it, but I don't know if it's going to help very much unless you really practice this a lot first. So again, taking a look at this right here, what if I do that circle example like I did last time? Well, if I go ahead and drag this circle out here, and then I go ahead and lock the circle in place with the point A, you will see that I can start to rotate this. You call this one the preimage, call this one the image. I'm going to start rotating this a certain amount. If I go all the way down here, like even notice where this green point goes. When this goes all the way down to 90 degrees, right there. This is about the origin, by the way. Now this point is up there. And this is for a 90-degree rotation counterclockwise. And that's, once again, where A prime is. And you could keep doing this over and over and over again. And you can see all these different kinds of rotations. Now notice that it won't be very beneficial to do like a 30-degree rotation like that. It's not even sitting on a proper point here. So the only kinds of rotations you'll be seeing on graphs here are 90, 180, and 270 degrees. So just make sure you keep that in mind. So all these points, you're going to notice some patterns about these if you really do pay close enough attention, and if not, I'm going to be telling you about them anyway. But you'll be noticing some patterns here that will apply for all different kinds of rotations on graphs with regard to points, mostly about the origin, which not all of your problems might always ask you about problems rotated about the origin. They might be about another place as well. Anyway, so we now have our A prime. We know where that one's going to be. It's at -2, 6. Let's go ahead and get rid of the circle. And then let's go ahead and plot that point A prime here at -2, 6. Okay, the rest of the rotations that I'm going to do here is based on that paper rotation thing that I was talking about. Let's go ahead and see how that's going to fit in. So if I group these guys up, I'm going to go ahead and do a rotation here. Let's find out where 180 degrees rotation will go. Now for a 180-degree rotation, one way you could do it is if you take that piece of paper and rotate the entire paper over. So here's 90 degrees, and if I go another set, that's 180 degrees. Notice where A double prime, I'll call it A double prime, will sit. It looks like it's at -6, -2 there in the third quadrant. However, I didn't need to do that. I could have, and I will. I'll mark that place just fine. But another way I could have rotated it I already have A prime, and this is already a 90-degree rotation. Here's your 90 degrees right here. So if I do another 90 degrees right here, just from A prime, I can also get to A double prime right there. And that's a 180-degree rotation total from A, which was originally there, 180, all the way over there. So A double prime is sitting at -6, -2. Let's go ahead and get that answer in there. Now, one last one is 270-degree rotation. And for this to pan out, let's see, let's plot this point as well. Okay, for a triple prime for the 270-degree rotation, I want you to think about how that would come into play. What are the shortcuts involved as well? I want you to think about those. Some shortcuts, besides just, 270 degrees is fully over here. Think about what we said last time shortcut-wise. You could also do a 90-degree rotation about A double prime. You could also do a 180-degree rotation about A prime. And besides the 270 degrees here for A, notice that 270 degrees counterclockwise is the same thing as 90 degrees clockwise. If I rotate that 90 degrees clockwise here, look where A rests, at that final point where A triple prime will be, -2, -6. +2, -6. So let's go ahead and plot that point, and then let's write this down, then we'll plot the point. Then we'll say that we're done, but in case any of that got confusing, or in case you feel like rotating your paper becomes too hectic and you get lost in your own work, I'm going to try and give you two more little tidbits of information that could help you. One that I don't think you should rely on, but if you have the tool, I want you to know how to use it. And another, which I do, which after you practice this over time, you start getting used to. So first way I'm going to talk about is, let's talk about this point, or any general point. If you have some xy value, such as 6,2 right here for A, when you do the first 90-degree transformation counterclockwise, notice what happens to the values here. Your 6, does your 6 exist over here? Yeah, your 6 still exists here. Your x value in your preimage becomes your y value in your transformation. Now I'm going to write x, but that's the value. It's in the y location. So if this was 4, this would be 4, etc. So all I'm saying is that just goes over there after the 90-degree rotation. This y value exists as well, only its sign changes. It becomes opposite of what it was before. So as it was +2 before, it becomes -2 for the x value, if that makes sense. So this point that was at 6,2 for xy is now at -2,6 for xy. So that's kind of a nice, interesting thing you can talk about. And you can keep going along this route, try and tie in once again. Okay, so this 6 before that was x, or this 6 before that was x, has now become -6 in the x coordinate. So -x, the opposite of it, and it looks like this is still opposite y right here, as that -2 becomes -2 here, or this 2 is -2 here. And the last rotation, triple prime, 270-degree rotation about it, your original y value becomes your x value over here. So y goes over there, and then your original x value becomes the opposite over there, and it goes in y. So if you had these memorized in some way, I'm sure you could use it. I just want to let you know that after, I can't say I've done years and years of it, but after having done it for a long enough time and being a teacher and recognizing whatever, this is not what I do. Okay, I don't memorize these, I don't put these in place. But if you did have this tool handy, or if you did want to refer to this, or if you wanted to write it on your own, after that you can. You can, C-A-N. What I'm going to ask you to do, myself, even if I'm not your teacher, what I'm going to ask you to do for all math problems is always find your own little shortcuts to things. As long as it makes sense with what you're doing, and as long as you can understand it, maybe even reteach it to someone else. Now, I don't know if I can reteach this to you, but I want you to take a listen to what I'm going to recommend here. Besides the paper turning, which is completely viable, notice what I did when I was turning my paper. I was in the first quadrant here, Then we went to the second, third, and fourth. We started at A, our preimage. Then we got to A prime. When I first was talking about paper rotation, I said your x-axis will rotate, so it then becomes where your it goes where your y-axis was. So the way that I kind of do this is, first of all, I recognize that these numbers kind of stay the same, but they're placed differently. So all I have to figure out on my end is, one, what quadrant will it end up in after a rotation? And two, does it, which axis does it stay close to? Okay, which axis does it stay close to? That's the next thing that I do. Because if this was short before and long, now it'll be tall and skinny, right? That's short and wide and tall and skinny. That's something that I recognize, and then I just got to remember what my numbers were. So as this was 6-2, I know that a 90-degree rotation will put me in the second quadrant. I already know that. You do this enough, you'll know what quadrant you're going to. Now, I know that A was close-ish to the x-axis. Now, after a 90-degree rotation, everything should turn like this. A prime will now be close to the y-axis. Remember, x-axis becomes y-axis in a way. So as A stays close to it over here, I do a rotation in my head. I know that A will stay close to here. So I know that as it was short and wide before, now it becomes tall and skinny. Now all I need to recognize is what my numbers were, and then I know where they go. It's kind of weird to talk about, but after you do this so many times, I think it's a really helpful thing to do. And it's going to help a little bit more probably for the next example that we do. But really what's important is distance away from your pivot point. This was 6 units away and 2 units away here. This is -2 units away and 6 units away here, etc. You use distance formula, right? Triangle, stuff like that. These have to be the same distance away from each other as they originally were. But notice how these all come into play in such a way. These distances stay the same from each other. Now they might not always be, the pivot point might not always be on the origin, but this radius still, the transformation, all of them will be equidistant from that point. Okay, the final one I'm going to do with you is an example where it's, first of all, it's a full object. So as you remember from the first example, I'm just going to do one point at a time. But this one's not going to be about the origin. This one's going to be about a different point. This point's going to be 2, -3. Now, in order for this to actually work, you have to first probably plot the point. Here's 2, -3. Everything's going to rotate about this point right here. Next thing I would ask you to do, this is where stuff kind of gets confusing. We're so used to these axes being our rotational focus, if that makes sense. Meaning when I was asking you to turn your piece of paper 90 degrees, you would essentially be rotating it like this. So it would be rotating about that. But I'm not asking you to do that anymore. Now we have to find a different source of rotation. And that source has to be about this point right here. So if you can, try your best to probably create new axes in a way. Like I'm going to make kind of a new y-axis here. The cross section of x equals 2 and y equals -3 will be pivotal to success here. Everything's now going to rotate about here. This is like your new origin, and that's the best way that I can put this. I don't think I should try and put it another way. This is like your new origin. So if you're thinking about what we talked about before, if I want to make this a little bit shorter this time, what I'm going to do is take a look at counting the distances away from this origin for every point. I'm going to start off with C. Okay, we exist in quote-unquote the second quadrant here, where we went 1 over and 2 up. C, in this sense, is closer to the, let's see, so C is at -1, 2. C is closer to the quote-unquote y-axis than it is the x-axis. I'm going to go ahead and rotate this counterclockwise. If I rotate it 90 degrees, C, your y-axis will become your negative x-axis, so C will be close to your negative x-axis. Okay? That means it's going to be 1 away from your negative x-axis, and it's going to be 2 away from your negative y-axis over here. This is where C prime exists. If you don't get this, you can rotate your paper. I can't rotate this. Sorry, I shouldn't call this C prime. This is a 90-degree rotation. I'm going to do 180. But anyway, I rotated from here down to here for 90 degrees. Okay, here's the 90 degrees right there. I'm doing that rotation. I'm going to do 180. But anyway, I can't rotate this about this with my software, so I'm doing this for you, my explanation. When I do another 90-degree rotation to get fully to 180 degrees, notice C prime, I'm calling it C prime, is really close to the negative x-axis here. So when the negative x-axis becomes the negative y-axis, C double prime will be very close to the negative y-axis here. This will be 1 away from it, and it'll be 2 away in the fourth quadrant from here. So C double prime will exist right there. I'm actually going to put it on the other side here, C double prime. So my C double prime, the one that I was focused on, is going to be at the point. Now, it's not really at -1, -2, by the way. I was just putting that really there. Where was it really? It was at 1, -1, right? See, this is where I'm going to confuse you too much. C is really at 1, -1. Where is C double prime really? It's not really at 1, -2, right? It's 1, -2 away after this shift of 2, -3. It's at 3, -5. You know what? I should cross this one out. I should have mentioned that. C is at 3, -5. C double prime. The image, after you rotate it. Quadrilateral, A, B, C, D. All right, let's do B. I think B might have been the easier one, but I still wanted to make sense of all this stuff. B is 1, 2, 3, 4, 5, 6 units away from the new origin. When I rotate it 90 degrees, B on the y-axis will now be on the negative x-axis, directly on it, 6 away. So here's B prime. If I rotate it another 90, it'll also be 6 away on the negative y-axis here. Here is B double prime. Okay? That point is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. This point is at 2, -9. Okay, let's do D. This would have been nice if this was its origin, but it's not. Now D, if you imagine it's closer to the negative x-axis, this point is at 1, 2, 3, 4, 5, 6, 7, 7. 7 away from the x-axis here, and 3 away. I'm sorry, 7 away from the y-axis, 3 away from the x-axis. When I rotate this 90 degrees, this will now go 7 down, 3, 4, 5, 6, 7. Now it'll go 3 over, because notice it's going to stay, 3 over this way. Because notice it's going to stay this distance away from this axis now, 3 units away. That's just really the best way for you to remember it. Once again, remember what your numbers are, 3 and 7. 3 units away, 7 units away. Which way should it be? How far apart should it be? Another rotation of 90 degrees will bring it 3 away from this axis and 7 away from this axis. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. There's my D double prime. Okay, last one right here, A. We're going to go 1, 2, 3, 4 away from the y-axis. 1, 2, 3, 4. That's closer. It's closer to the y-axis than the x-axis. 1, 2, 3, 4, 5, 6 up over there. So it's closer to the y-axis. Here's 4 away. Here's 6 away. When I rotate this way, think about the y-axis going to negative x. Now it's going to be 4 away from here. And it's going to be 6 away from here. So 1, 2, 3, 4, 5, 6 away, just like B was. And 1, 2, 3, 4 down. This one was A prime. A double prime will be another 90 degrees. If it's 4 away from here, after a rotation, it'll be 4 away from here. And it'll be 6 away from here, as it was 6 away. After a 90-degree rotation, it'll be 6 away. So 1, 2, 3, 4 away from there. 1, 2, 3, 4, 5, 6. That will be A double prime. So my final image, as I connect all those ones in there, I know it's kind of a small drawing and maybe even a little confusing there, but let's kind of see if I can do the best I can here. Let's connect these points. And this image is a 180-degree rotation. about the point 2, -3, right? This is no longer about the origin. This one did a 180-degree rotation, and you might be able to understand what the rotation looks like, but it's a 180-degree rotation, and it was about this point now, was not about the origin. So if I'm rotating, this is your new axis, your new origin, in a way. And that's really what I think you should think about that with. And if you took your pencil, what you could do is draw really thick lines, count how far, oh, I have to plot these other points. A double prime is at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, -9. D double prime is at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 9, -6. I think I did that right. Anyway, so you can draw new axes. Draw them plenty dark, because if you already have axes on your paper, you really want to not focus on them. You can take your pencil and literally plot it there, and you can kind of spin your paper around there. Think about 180 degrees and how far away C was in relation to this new origin. 1 away, 2 up, and now it'll be 1 away that way and 2 down in the end when you find it, and that's where you'll plot the point. But the end point, the end result, if I could literally erase everything else on this except for the original pre-image and the new image, let me try and do that. If I could get rid of everything else, even the axes there, that's as close as I can get, or so it seems. This is what the rotation looked like in the end. Now you can't see how you can't really notice where it was rotating about. You can probably find the center point, but that's going to be really hard for you to determine unless you draw new axes with it. But there's rotation. Hopefully it made sense how rotations kind of work. They're not the same as reflections. Okay, they are not the same as reflections. For 180 degrees, I know how you can think of it as one, but if it was reflection, say across a line like that, then B prime would be over here. D prime would be over here, but they're not. You can see that this rotated in such a way. All right, hope that was fun. Hope it made sense, and good luck with what you got. Fiend!